Hello viewers, welcome to my physics channel. For this video, our topic is electric dipole. Also, we will derive expression for electric field due to electric dipole. So, let's see what is electric dipole. Electric dipole is a system of two equal and opposite charges. Like we have two charges plus Q and minus Q. A system of two equal and opposite charges means magnitude is same and nature is opposite. So if we have a system of two equal and opposite charges separated by certain distance, it becomes an electric dipole. Like we have plus Q minus Q and these charges are separated by a certain distance. And suppose this distance is 2a, then it becomes electric dipole. Why we take 2a? We can take a also. We have taken 2a just only for simplicity of calculation. Otherwise, we can take it as a also. Now, this is electric dipole. And this 2a is called dipole length. 2a is called dipole length. One term is associated with this electric dipole, that is called electric dipole moment. Electric dipole moment. It is denoted by the symbol P, and electric dipole moment is a vector quantity. Electric dipole moment is equal to product of magnitude of charge, and this dipole length. So this is, what is magnitude of charge? Q, and what is this dipole length? 2a. So dipole moment is equal to Q into 2a. Now dipole moment is a vector quantity. What is direction of dipole moment? Direction of dipole moment is from negative to positive charge. This is direction of dipole moment. Because it is a vector quantity, so this length, dipole length, is assumed as vector. So here we will put vector sign. So we can say this P is equal to Q into 2a. This is dipole moment. So P is equal to Q into 2a. This is formula for dipole moment. It is a vector quantity. And what is unit of P? Unit of P is, what is unit of charge? Coulomb. What is unit of length? Meter. So it is written as Coulomb meter. We can't write it as meter Coulomb because it will be read as millicoulomb. So this is not the correct way to write unit of dipole moment. It is written as capital C, that stands for Coulomb, and it is meter, Coulomb meter. Now we derive expression for electric field due to electric dipole. So first is electric field on axial line of dipole. Electric dipole means we will derive expression for electric field on axial line of dipole. Now suppose we have an electric dipole AB. AB is an electric dipole having charges plus Q and minus Q. Now suppose this is minus Q, here we have plus Q. And what is dipole length? Dipole length is taken as 2a. So what is dipole moment? Dipole moment of this electric dipole is given by electric dipole moment. Electric dipole moment P is equal to Q into 2a. And what is direction? Direction is from negative charge to positive charge. That is from A to B, minus Q to plus Q. That is from A to B, means along AB. So suppose this is equation 1. Now we have to derive expression for electric field on axial line of dipole. For this we consider this axial line, means that is acting along the axis of this dipole, means line joining the center of these two charges. So this is axial line. Here we assume a point X. Now suppose P is the point at which we have to find out electric field, and this point P is at a distance r from the center of dipole. Suppose this point C, this is center of dipole, and distance of point P is r from center of dipole. So we have to find out electric field at P. Now how many values of electric field are acting at P? 2. One is due to charge at A and second one is due to charge at B. So let us take electric field at P due to charge at A. Suppose its value is taken as EA. We know that formula for electric field due to a point charge is E is equal to Q upon 4 pi epsilon naught R square, where R is distance of that point from charge. One more thing is there, this system is taken in free space or air, because we are taking this value epsilon naught. Naught stands for like the system is placed in air or vacuum. So here EA is equal to Q upon 4 pi epsilon naught R square. What is distance of P from A? AP. We have to take this AP square. What is this AP? Let's see. This AP is equal to this R plus AC. What is AC? AC is half of 2A. So we can write this is A and this is also A. So what is AP? AP is written as this R plus A. So we will put value Q upon 4 pi epsilon naught R plus A whole square. What is direction of this electric field? We know that for negative charge, direction of electric field is inwards, means towards the charge. So this is negative charge. Here we have to find out the direction. So this is direction of electric field. This is EA. So it is along PA. Okay. Now we have to find out electric field at P due to charge at B. Suppose its value is EB. So it is Q upon 4 pi epsilon naught. What is this distance? Distance of P from B. This is BP. So it is BP whole square. Now what is value of BP? BP. It is this R minus this CB. What is CB? A. So BP is R minus A. We will put this value. It is equal to Q upon 4 pi epsilon naught R minus A whole square. What is its direction? This is positive charge. For positive charge, direction of electric field is outwards. That is away from the charge. So this is positive charge. Here we have to find out direction. So this is away from the charge. Means this is direction of EB. So this is along PX. Now we have to find out resultant electric field at P. We know that electric field is a vector quantity. So resultant electric field is vector sum of these two values, that is EA plus EB. So we have to take vector sum. Now we see these two values are acting in opposite directions. It means resultant is calculated by taking difference of these two values. So E is equal to difference of these two values. Now which one is greater? EB is greater or EA is greater? Let's see. Both charges are same, magnitude is same, and B is closer to P. So obviously its influence is more at point P, means electric field at P is greater due to charge at B. So we can say EB is greater than EA. Also we can say, if we see these values, here we have R minus A whole square and here we have r plus a whole square. In this denominator is small, so obviously this value is greater. So from here also we can say EB is greater than EA. So what is this E? It is taken as difference of values, these values. So E is equal to EB minus EA. Now we will put these values. E is equal to EB minus EA, that is Q upon 4 pi epsilon naught R minus A whole square minus Q upon 4 pi epsilon naught R plus A whole square. This implies E is equal to, now Q upon 4 pi epsilon naught is common. Here we have 1 minus R minus A whole square minus 1 upon R plus A whole square. Now this is, we take LCM, that is Q upon 4 pi epsilon naught, again this is common. LCM is, this is A minus B, this is A plus B. So LCM is A square minus B square, that is R square minus A square, and here we have whole square. So here we have R plus A whole square and minus R minus A whole square. We will simplify this. So we get Q upon 4 pi epsilon naught. We will simplify this. R square plus A square plus 2AR. Here we have minus sign, so all signs will be changed. R square minus A square. Here we have minus 2AR, so it becomes positive, plus 2AR upon R square minus A square whole square. Now R square and A square, these two terms are cancelled out. So E is equal to Q upon 4 pi epsilon naught 2AR plus 2AR, that is 4AR upon R square minus A square whole square. Now we can write this as E is equal to Q into 2A. Means this 4 is written as 2 into 2 into 2R upon 4 pi epsilon naught R square minus A square whole square. Okay. Now from equation 1 we see Q into 2A is equal to P. So we can use equation 1. So it becomes E is equal to P into 2R upon 4 pi epsilon naught R square minus A square whole square. So this implies E is equal to 2PR upon 4 pi epsilon naught R square minus A square whole square. This is expression for electric field at any point on axial line of dipole. But this is only magnitude. What about direction? We know that when we subtract these two values, direction of resultant vector is always along the direction of greater vector, that is along EB. What is direction of EB? Along PX. So resultant will be along the direction of EB, means obviously it will be less than EB. So this is direction of E, that is along PX only, along PX only. Now we see this is direction of resultant electric field. What is direction of dipole moment? Dipole moment is always along negative to positive, means dipole moment is from A to B, electric field is along this direction. So we can say at any point on axial line of dipole, direction of electric field is same as is of dipole moment. So at any point on axial line of dipole, direction of electric field is same as that of electric dipole moment. Now we can take special case also. Special case is if dipole is of very short length, means this dipole is very small. So we can say this 2A is very small. 2A is very small. So obviously A is very small. If A is very small, So we can say A square is very less as compared to R square. Now this A square is very small as compared to R square. So we can say this A square can be neglected. If this is neglected, then we can say E is equal to 2PR upon 4 pi epsilon naught. This is neglected. R square whole square, it becomes R raised to power 4. 1 R is cancelled out. Here we get R raised to power 3. So this is equal to E is equal to 2P upon 4 pi epsilon naught R cube. This is electric field at any point on axial line of dipole due to short dipole. Means if dipole is of very short length, then this is the expression for electric field on axial line of dipole. Okay. Now we will derive expression for electric field on equatorial line of dipole. Again we consider one dipole AB having charges minus q and plus q. Again dipole length is taken as 2a. Now we take any point on equatorial line of dipole. What is equatorial line? The line which is along perpendicular bisector of this dipole. So let's draw this perpendicular bisector. So here is the point P. Suppose this P is the point at which we have to find out electric field. So first of all, let's take the dipole moment. What is electric dipole moment? Electric dipole moment P is equal to Q into 2A. What is direction? Direction is negative charge to positive charge, that is along AB. Along AB. Now this is equation 1. Now we have to find out electric field at P due to this dipole. Two values of electric fields are there. One is due to charge at A, second one is due to this charge. So first we calculate due to this one. EA. We know the formula. E is equal to Q upon 4 pi epsilon naught R square. So we will put values. What is EA? Q upon 4 pi epsilon naught R square. What is this R? AP. AP whole square. Let's calculate AP. What is AP? AP is, if we complete this triangle, we can say this AP is equal to BP is equal to, AP will be equal to BP. So we can say, if we take this triangle ACP, in triangle ACP, AP square is equal to AC square plus CP square. So suppose this CP is taken as R, means the point P is taken at a distance R from the center of dipole. Okay. So what is AP? AP is equal to BP is equal to square root of R square plus this CA square, or we can say CB square. What is this? A. This is also A. This is also A. So this is AP. Here we have to take square. So this square root will be cancelled out. It is Q upon 4 pi epsilon naught R square plus A square. What is its direction? Because this is negative charge, so direction will be towards the charge. Means this is EA along PA. Now we calculate EB. EB is electric field at P due to charge at B. What is EB? Q upon 4 pi epsilon naught BP square. What is BP? We have calculated BP. Its square, we have to take its square. Q upon 4 pi epsilon naught. This square root will be cancelled. So This is value of EB. What is direction for EB? This charge is positive, so electric field will be acting in outward direction. So away from this charge. This is direction of EB. That is along BP produced. Now we have to calculate resultant of these two vectors. Suppose E is the resultant electric field at P. So E is written as EA plus EB. Now two ways are there to simplify this. See, this is isosceles triangle. So these two sides are equal. AP is equal to BP. So both these angles will be same. This is theta. This is also theta. If we draw horizontal line here, then we see if this angle is theta, this angle is also theta. Corresponding angle. And this is theta, so this angle is also theta. Also we can say exterior angle is equal to sum of opposite two interior angles. We can take anything. So this is theta, this is also theta. It becomes 2 theta. One method is to simplify is this, that we can use triangular law of vector addition. Means we can see that use that resultant, that E is equal to square root of EA square plus EB square plus 2EA EB cos theta. We will put all the values. Also we will put this cos. What is cos? Angle here 2 theta. Then in this triangle we will put value of theta. Second method is we can resolve EB and EA into components. So this one is very simple. We will use the second method. Now we will resolving EA and EB into components. Rectangular components. We know that this angle is theta, this is EA. So if we resolve it into components, in this direction EA cos theta will be acting, and here we have EA sin theta. So here we have EA cos theta, and this is direction of EA sin theta. Similarly, we can divide EB into components. Here we have, this is theta, so along the direction of angle we have cos component, that is EB cos theta, and perpendicular to that is EB sin theta. Now we see magnitude of EA is same as its magnitude of EB. So here we have EA sin theta, here we have EB sin theta. We can say sine components being equal and opposite will cancel each other, because these sine components are equal and opposite, so they will cancel each other. So resultant is only because of cos components. And what is direction of these cos components? Along this horizontal line. Suppose this point is taken as X. So resultant electric field is due to cos components only. So resultant electric field is taken as E. So it is EA cos theta plus EB cos theta. Now magnitude of EA, EB is same. So we can replace this by EA. It becomes 2EA cos theta. Now we have all the values. We can put the values. It is equal to 2 into EA. What is this value? Q upon 4 pi epsilon naught R square plus A square. And what is this cos theta? We can take this triangle ACP. In triangle ACP, we have to find out cos theta. We know that cos theta is base upon hypotenuse. What is base? This AC, that is A. What is hypotenuse? This AP. What is AP? Square root of r square plus a square. That is r square plus a square whole raised to power 1 by 2. We will put this value here. So it is a r square plus a square whole raised to power 1 by 2. If we see in numerator, we have q into 2a. And what is q into 2a? That is dipole moment. So using equation 1, we can replace this value by p. So it becomes E is equal to p upon 4 pi epsilon naught. Here we have r square plus a square whole raised to power 1, and here we have the power 1 by 2. So it becomes r square plus a square whole raised to power 3 by 2. Powers will add up. Now, so this is expression for electric field on equatorial line of electric dipole. This is only magnitude. What about direction? This is direction of resultant electric field. Addition of these two. This is acting along this direction. So this is direction of resultant electric field. That is along px. Now in this, what is direction of dipole moment? Dipole moment always acts along from the negative charge to positive charge. So this is direction of dipole moment P from A to B, and resultant electric field on equatorial line of dipole is acting in this direction. We can say direction of electric field on equatorial line of electric dipole direction of electric field on equatorial line of electric dipole is opposite to that of dipole moment. Means we can say anti-parallel. Dipole is acting in this direction, electric field is acting in this direction. So electric field and dipole moment are anti-parallel. Now we can take special case also. If dipole is of very short length, if electric dipole is of very short length, we can say this A is very small. So A square is very less as compared to R square. This A square can be neglected. So we can say in this expression this A square is neglected. So it becomes E P upon 4 pi epsilon naught. Here we have R square whole raised to power 3 by 2. This 2 will be cancelled out. We have R cube. This is expression for electric field on equatorial line of dipole due to short dipole. Okay. Direction is anti-parallel. On axial line, it is same as is of dipole moment. One more thing is there. For a short dipole, if we compare electric field, then we see E axial is equal to 2E equatorial. Means electric field on axial line is equal to twice of electric field on equatorial line. Here we see expression for electric field on axial line of dipole, that is 2p 4 pi epsilon naught r cube. Here we have expression for electric field on equatorial line of dipole. So electric field on axial line is equal to twice of electric field on equatorial line of dipole. This is for a short dipole. Next topics will be covered in the next video. Subscribe for more videos. Thank you.